You do plan.
Yeah. Yeah, exactly. Like the plan is to actually make this happen on eCash. But it's not high priority at all. Everybody I talk to is like, no, this is not really needed. But I think it's cool to have this thought through way before then do we even start working on this. And we already have the integers, right? So we have the integers. So this is a huge step, a small step for mankind, but a giant step for eCash. Yeah.
Yeah, for Mitra. Yeah.
I just came out with it. Actually, this is like really funny. A small step for mankind. So basically, this is like a useless thing, right? So yeah, so the new transaction, like it has the version, you can see it dropped the lock, what's it called? The lock time. It's no longer part of the mainline C transaction format. It still has all the inputs. It still has all the outputs, but it has two new arrays, so to speak. One of them are the preambles, and that's where all the token magic happens, right? And it also has the metadata. This metadata really is nothing special in the transaction. This really is like, do you have a height lock or a time lock? So you can either, so in the old code, you just encode this in the integer, right? If it's below 500 million or something, it's a height. If it's up above 500 million, it's not a height. But this is weird. I mean, Dogecoin already has 5 million blocks. So in 100 Dogecoins, this just breaks, right? I mean, this is 100 years out or something, but you know, like, why not make it future proof forever, right? So this
And
just
why
makes
is
it.
it called metadata when it's like lock times?
Say what?
Yeah, why is it called the group is metadata, but it's actually a lock time?
No. So metadata is okay. Let's jump into metadata. Where is it? Metadata. So this is an array of these things that I'm going to talk about next, right? An array of C metadata, and a metadata has one type and one payload, right? Like it's a key value thing, right? And the keys can be for a transaction. It can be height lock, right? Like 0 is height lock, 1 is time lock, right? So it's basically a key value. If the key is 0, then this means what follows is a height. If the key is 1, what follows is a time, right? That making sense? And it basically is like, okay, if you put into this dictionary, if you put 0 and then, like, I don't know, 800,900 809,000, whatever, then this transaction is only mineable after that height. That making sense? And the same for the time lock. It's just two different fields. And in theory, you could have both. You could both lock by height and by time, which previously didn't work. I don't know if that's ever useful, but maybe you're like, oh, if either of those, if both of them are true, then it works. Maybe you need to find some smart contract stuff. I don't know.
Yeah, so what you call metadata is kind of like optional extensions to the transaction.
Exactly.
Okay.
It's like, this is what not Satoshi, the other Satoshi, Amaury called it in what Amaury called it in his spec, right? Because he already has this spec. Maybe we can actually find it. Yeah, there we go. It's the only thing in my entire history that uses this combination of letters, and he has this metadata thing, right? Option metadata. So he has that model. He called it metadata, so it just reduced that term, basically, if that makes sense. So that making sense, this field? This is probably one of the easier ones to grok, but it's good that we have this now already, because we actually reuse this structure in other places. So let's jump into the next easy thing, which is the C out. And here, so I'm jumping around a little, but this is in the order of where it's easier to explain in my heuristic of easy to explain. So the amount stays the same, except now this is a compact integer, right? Previously it was always 8 bytes. Now it's a variable, just to make it more compact. The type. So this basically, it throws away the idea of output script. It just has an output type, and then you have the payload, and you just encode it in an integer. honestly, I don't care, but like I'm always like, no, we absolutely have to have this, and I'm like, okay, whatever, we can have this. But basically, this is like an enumeration of all different kinds of scripts that we want to have, and then
Yeah, so
different kinds of
it
hashes.
does away with the custom locking scripts. Like
Yeah,
there's just 4 types, yeah.
yeah,
And it does
exactly.
away with some of the archaic types, like the pay to multi-sig or something.
Yeah, and I mean, if you want to have those, you can use a pay to script hash, right?
Yeah, sure. I was just
Yeah, but you're 100% correct. And here now you can see, oh, we got an old friend here. I mean, we just met him, but our new friend here, the C metadata. And here you can see the metadata is there's 2 fields already. Maybe there's going to be more. I also wanted to add a kind of like NFT commitment, but it has the preamble index and the preamble amount. You can already think about this a little bit like a cash token. But the amount here, there's nothing in the transaction format itself that enforces this amount, right? So you could literally set this to any number whatsoever, and the transaction format itself does not care, right? So this is more like a field to put an amount at, like a placeholder almost. I mean, it'll make sense more, but so far, does it make sense?
Yeah, so it's not consensus enforced.
Yeah, so this is not consensus enforced, and this preamble index basically just references one of the preambles because there can be multiple ones. Yeah, and every output can only have this once, right? So if you provide this multiple times, invalid. All right, so now we'll get to that, and the input is just a normal input, right? Nothing special, except in the new format, we also contain, every input also contains the full output. So it's self-validating, right? If you get a transaction, it already has all the UTXOs, they have to be there. It's consensus, right? And that way, if you get a transaction, you can validate the entire thing, start to finish, without ever looking at the blockchain.
Yeah, that's an interesting design choice because it does like duplicate a lot of data, right?
It duplicates a lot of data, and intuitively, that's why Satoshi didn't do this. He's like, "What? Are you crazy? This is so inefficient." But when you actually run the numbers, this makes it much more efficient, right? Because like the data you waste by duplicating it here is so much less than the data you save, or like the bandwidth and the CPU and like the weighting and the complexity that you save by having it here. That making sense? Kind of.
Yeah,
I mean, I'm hand waving it a little bit. I can get into details there, but this is basically the crazy thing about this transaction format is that it bundles 2 things together. It bundles Project Hamilton and it bundles cash tokens basically into one thing, right? So that's why I was always a little bit upset with cash tokens, because like, wait, you can't do both things, right? But I'm like, yeah, okay, I guess it's a little wacky, but like that's the idea behind behind Mitra, is like we both and there's some like in eCash, everybody's happy with the Project Hamilton part, but the cash tokens part, people are like, I don't know, I don't want to add this, but I'm like, hold on, it's actually
So yeah,
actually
I would say definitely if you introduce a new transaction format, and yeah, you want to make all these like optimizations. But yeah,
right.
the thing with cash tokens is it was like backwards compatible, or like it didn't break the existing transaction format. Yeah, so
100%.
that was
Yeah,
trade-offs.
and here with the metadata, the metadata also has a very peculiar design. It is actually designed on 2 different levels, one which is wallet level and consensus level. It is made such that wallets will never ever have to like do another transaction format change, but we can add more and more fields to transactions, right? That's why this is so flexible. The original design is actually from, what's his name, Tom Zander. Do you know that guy?
Yeah.
He came up with the flex trans. He called it flex trans, which sounds super gay, but it's
Yeah, I never looked into it, but now that you explain that you can just have like extensible transaction fields, it does like make sense.
exactly, and it makes it more compact in some cases.
Because you don't want to have like a 5th and 6th transaction version, and then 7 and 8.
Exactly.
Like,
This should be a one-time thing, and then we never ever change it again. We still have the version field in case in 5,000 years people are like, oh, actually, let's add a new transaction format. We now have what's it called? We don't use binary anymore. We use ternary, so we need a new transaction format. I'm just kidding. By the way, IOTA did that, which is indefensible in my opinion. But
That's so funny.
no, yeah, it's funny in the for the first 5 minutes, and then you look into it and like, okay, like there's the NAP, but like for some things. No, I'm just kidding. For legal reasons, that's a total joke. Yeah. So, and here in the input, you can also see that you can see that this has the amount of the input that this preamble has. Now that I see that, that's actually redundant with this field right here. So maybe I'll drop it, but or maybe we don't include the. Yeah, there's still some design work. Now that I see it, there's still some
Work in progress. Yeah,
it's
definitely.
a total work in progress. So it's good that I'm sharing this with you right now. But you can see here it has the preamble hash, right? Which is kind of an odd thing, right? So the input contains of that input, it contains the preamble hash. So what is this? The preamble hash is basically whatever the preamble hash is of that output with this index. So what is the preamble? By the way, if did this hand wave explanation? I'm kind of going top down.
Yeah, so for the preambles, I do know that they're meant to like enable recursion, so you can do token schemes, but also like smart contract state. So yeah, just very high level. I wonder, why is it best to have like a preamble proof and not just have the consensus layer validate these proofs? Like what is kind of the thinking that goes into this?
Yeah, I'll get there.
Okay.
And I'm not sure if that's good didactically to be like, yeah, this is a brilliant concept. And there's actually a spoiler. Oh, we looked at it already. Oh, there it is. Oh. But the reason is that it's much more flexible because we actually use script, which is still consensus, to do this enforcement. So in a second, so I said this amount is not consensus enforced, but it is, but in script, right? So we can actually, let's do that. Let's take a really simple example. I mean, it looks complicated. So we also get like all these opcodes, right? So it does contain introspection, except they're like cooler. I don't know. They're very streamlined. Like they only contain what is super duper useful. But yeah, so very quickly, let's go through them. We have this like pick preamble hash, pick out point, pick input preamble hash, like all this stuff that is in the transaction format. You just get it. By the way, one thing that like was super difficult for me is that like, how do I encode out points? And I was like, okay, does it use the old encoding? Does it use the like compact integer? Because that's how it's actually encoded. But then I was like, wait a second, we're on script. We can just put two results. One is the transaction hash and one is the out point, but in integer encoding of script. That making sense?
Yeah, so you get them as a package deal. Yeah, and things can push multiple elements to the stack. Yeah.
Yeah, script type. Yeah, and same with script, right? Because like now we have this type. So I just push both of those here, which is a little odd, but whatever. Amaury demands it, right? The king demands it, so it has to be done.
So the only thing that yeah, it might add more overhead, because if you get these two elements in a row, you need to juggle them on the stack, right? So
yeah,
imagine you first want to do like a check against the transaction ID and then later against the vote, then you kind of need to operall or need to alt stack. So I think those are like considerations that it actually might end up bigger than just having two endpoints, but yeah.
Yeah, I agree. But like here in this case, usually it seems that if you actually want to get the input out point, well, and also like like we're not trying to like code golf this, right? Like this is not like, okay, what's the smallest amount of what's the smallest amount of scripts that we could build? It's just like, okay, what's like a really simple implementation that we could do here? And this seems like one, but I'm happy to turn this into two opcodes, right? Like I'm not here to like minimize the number of opcodes either. And yeah, so basically this is actually extremely similar to how, like basically one-to-one almost how cash tokens work. So I'm going to explain this real quick. So this is a preamble script, right? So before I do that, basically a preamble is like one of these entries here. So basically this just splits out this all this prefix stuff. It just splits it out into its own field, right? That making sense? Into its own field in the transaction. And there we have the script, the locking script, which in case of cache tokens, the closest thing there is actually the capability. So think about the script as the capability, except it's not enforced by consensus, but I mean, it is enforced by consensus, but it's not part of the code, it's part of the script, right? And then witness is just because every script has inputs or can have inputs. So this is just the inputs there. And then metadata, this is just a placeholder because there's currently no metadata that I want to add for preambles, but
Yeah,
maybe
so
in the future.
Just for my mental model, so I assume, yeah, this would cover more than just fungible tokens and the basic capability. So what is the type of like preamble, yeah, that would be covered by this flexible script? Yeah, running this script. Like, what are some cool preamble scripts that you could
Yeah.
envision?
I wanted to show you one.
Yeah.
Here's an example, right? This is a simple token transfer, no mint baton, right? You create it once, that's it, right? So you create this. So every like let's start here. Let's start with the else branch because this is easy to understand. So let's assume we already have a token. Then it basically is like, hey, give me the preamble hash of this preamble, right? Because you can't include the hash of itself in the preimage, so we have to use the opcode to get the preamble hash, and then there's this opcode called input color sum. Now that I spell it out, it sounds totally horrible, but basically this is a really simple opcode.
Yeah, I get it. You sum all the tokens in the inputs. Right?
Yes, all the inputs, because the amounts, they're just there, right? They're just like fields, but it's like, okay, sum this up, and but only of those that have this preamble hash, right? So
yeah, makes sense. Yeah,
makes
so
sense.
you give it like a token ID kind
exactly. It just calculates the sum, right? It gives you an integer. Makes sense, right? So I don't need to backtrack there. And then the same thing for the outputs, right? Give me all the outputs. And
yeah, this makes sense as
then,
like a sending.
And then op equal greater or equal, right? Like, because like it has like, you can't create tokens out of nothing using this, right? So like, okay, well, that makes sense. And the genesis is basically like an exception to this, because like this thing, if you only put this in the preamble, it will be a transaction that is always invalid, right? It's a transaction that could mathematically never enter the blockchain, except if, of course, these are all like, if this is 0 and this is 0, right? But that's a boring, like, this is the only kind of preamble that can enter the blockchain if you never send any tokens. So you need to create a mechanism to create new tokens into existence. So here we actually do exactly what cash tokens does, like almost verbatim, where like it's a, hey, give me the zeroth or whatever, give me any input out point. That is actually given by the user. The user can specify which input out point. Then drop the v out. Probably we can put the v out to enforce it to be 0. Doesn't really matter, right? And then it puts like, this is the Genesis transaction ID, and then it does up equal, right? So this would be the category right after the
I see.
Right, and then you just do up equal, and then there's no restrictions, so you can just fan out a bunch of tokens, and they can reference that preamble index. That making sense?
Yeah, this makes sense.
Right, so this is already pretty cool. I mean, like this is and actually, like, this is kind of where it started at. This script, I knew like, I think I can do this, because I wanted to enforce SLP in script. Doesn't work. You have to go much deeper to do that. Spoiler. People try to do that. Jason Dressner tried to do that. And by the way, I think I'll send him this recording. Maybe he'll be like, "What is this? What is this waste of time?"
No,
anyway,
I don't think
he can block me.
No, I don't think he will.
So
I'm curious for the next example. So
yeah, next example, right? Like, I'm keeping the suspense. I can see you're suffering. I'm just a sadist like that. Yeah, that's why we forked off. Yeah, because we're all toxic sadists. Yeah. So here you can see how we can, so this is a mint baton, right? So this is something where you have an mint baton. And I was like, oh, this is probably super complicated. No, it's not. It's not at all. You just put like input preamble hash of the mint baton, right? So you have you just have two different token IDs, right? Like we have one token ID that is the valuable token, and you have one token ID that is the mint baton for that token ID. And the fungible, or like the other one, it like references it references that other token. So here you just do input color sum of that mint baton, and you just do 0 not equal. That's it, right? And then this one is the same as here, because you maybe want to keep alive the mint baton and stuff.
Yeah.
Right. That making sense?
Mm-hmm.
Right. So it's a really simple way of adding a mint baton. So here's a token that can just be inflated. Once you have one, you can just create as many as you want. So you might be, okay, why is this useful? But here you can see actually why this is useful. A mint baton. In SLP, you can already inflate mint batons as much as you want. You can just explode, like you just create as many as you want. And here you can see how this is useful. Here we just do pick input out point genesis, and then here in this one you can inflate it if you have at least one input token, right? That making sense? Okay, we can go.
I'm thinking about the difference with the previous example. So tokens that can be inflated at will, and the mint baton, they
so the one you probably should compare it to is this one, because basically, so here you can see the op if is this genesis thing, and this is the exact same thing as here, right? You genesis these inflatable tokens the same way, right? But then this code here is changed to be, okay, you can inflate tokens at will if you have at least one token, right? So if you have 0 tokens, you can't create it, because otherwise anyone could create it. But if you have one token, then you can create as many outputs as you want. That making sense?
Yeah.
So you can see how this could be a little tricky, right? So people have to be careful. This is more powerful, but it's also more dangerous a little bit, because like if you mix, like let's say this is a super complicated preamble, if you mix things up a little, it could be that people can just inflate the token, right? But yeah, if you have simple stuff like this, it's not a problem. All right, so another thing. 1 second, okay, my mom said food, so I have to be quick. But we're almost done. We're almost done. So for example, there's token upgrade. So this is also a relatively simple one. So here, this else branch is the same one as this one, right? So this is just a token that also has another if branch.
So what is allows upgrading old tokens to a new one by burning an equivalent? Okay, so you can kind of cycle the token ID.
Yeah. Okay. Yeah, change to a different token ID, and then everybody can upgrade them if they want, or if they don't, they can use the old one. So just check, hey, is the inputs, like, are all old tokens burnt, right? Every single one has to be burnt. And then the input color sum is then the same as the output color sum, right? So you burn 500 old tokens, the output has to be also 500. Yeah, but there's probably other ways to do this. This is just the first one that I came up with.
So I have a question. Yeah, if I have tokens I have tokens in my wallet, so those already have a preamble, right?
Yeah, every token has a preamble.
Yeah, but then I'm interacting with this kind of preamble, I guess. So I convert them into a new token type. What becomes the new token? What is does it combine the two preambles somehow, or does this become the new one?
This is the new preamble.
Okay.
Yeah. Oops. Where is it? Here. This becomes the new preamble. It's a little bit bigger.
Wraps another token and the wrap token.
Oh, yeah. So this is the token upgrade. All right. So let's move on to the next one. Wraps another token, and the wrap token can be released by burning the wrapper. Yeah. So basically, let's say you want to add like a crazy complicated preamble to, let's say, USDT, just as an example, uses Mitra, and they just are like, okay, we're USDT, we don't want anything fancy, let's use this one, right? And then later, like, actually, like, it would be cool if we could also do this and that and this and that in the preamble. So what you can do is you can just wrap a token. You can probably do this in cash tokens as well. You probably already have in mind how to do this, but I just wanted to see how this works. It basically is like, hey, I can anyone can create this token if they basically lock some tokens in a specific script, like this, a specific script, right? And type equal verify. Oh no, and then it builds the script, hashes it, equal verify, right? Like it basically builds actually the script, the wrapper script, right? You have that here. It includes because you have to have the preamble in there. Doesn't matter too much. And then it basically checks like, hey, at this input, right? No, at this output, does it actually correctly lock these tokens in this script? In this wrapper script, script.
Yeah, so I'm a bit confused how it enforces this preamble on like consecutive transfers. So is it only enforced once, or?
No, you actually have to, the preamble has to make sure that the previous ones also enforce it. But this is actually really simple because the script of the script of the preamble is the preamble hash. Maybe there's some metadata or something, but like it basically, the script of the preamble, this thing here, is the preamble hash. So simply by simply by doing this, you immediately enforce this recursion. That making sense? It's a bit of a mind blowing. Like I just bundle everything together in one thing. Like it's almost like it's like a monad almost. I don't know if you know what that is, but it's just like one thing that does everything, right? That doesn't make sense because I'm kind of
yeah, I think it does.
So let me explain it again, because you said you think it does, which means I don't understand. So you create this genesis, and it's just self-validating because of this thing. Now the next transaction, it will reference this input has this preamble hash, right? This input has this preamble hash, and then but the preamble itself is the same script code, right? Because it has to match, right? Like you take the preamble, the preamble gets hashed here, right? It's like my own hash. The hash of this thing is this result of this code, right? And it's like, okay, give me all the inputs that have that hash, or like the sum of the amounts of all the inputs that have that hash. So you know that all of those, they already ran this code. Is that making sense? It's a proof by induction, right? Like as I showed. I can send you this thing. It's a little.
No, but so for me, for transfers, it kind of makes sense because transfers are recursion, so you want to enforce the same thing all the time. But then for the wrapping, it's harder for me because wrapping only happens once in my mind. So then you have like the old preamble, then you have a wrapping preamble, and then you get a new preamble. So there's 3 preambles involved, or how many different?
No, there's two preambles in this case.
2 only. So
yeah.
But so, I mean, the wrapping part of this logic only gets invoked once, no? Or once by each user. So
every time everyone can wrap a token, right? So every time you wrap a token, you and by the way, once you wrap it, the preamble will be the same, so they will be fungible, right? If you wrap a token and another one, but this is not because of some enforcement. This is because everybody just has the same preamble, right? It's like, hey, if you want to wrap this, like for example, let's say some crazy smart contract is like, hey, I accept these kinds of tokens, but they have to be wrapped first, right? So you can use that specific hash in your smart contract, but you have to run this exact preamble in there. You could change it, right? Like you could change the order of these 2 cats. No, you can't. Like you could use you could use a different you could use a different script here, right? But
I see.
So that kind of making sense. I mean, you could dig into it. I could explain the exact stack and so forth. And I don't know if this actually works. This is just me typing it out because I'm a crazy guy like that.
So one use case I do see for preambles immediately is this could like enforce like that your tokens can be confiscated somehow, right? So
exactly.
That could be, okay.
This is one thing. Yeah. So you could externally burn. I think. Well, it's tricky because like you still don't have the script. You can't, like, you could do that actually, but it requires a little bit of work because you have to enforce which outputs, because the outputs are still outputs, right? The outputs are still scripts that have to be valid, if that makes sense. And if you have like a
I
public key
see.
hash, so it's tricky to do a confiscatable token,
Oh,
but
okay.
it could be done. It's just, it requires a little bit of work, which is good because we don't want to have that right away.
Yeah. Yeah, but it's good to understand that the outputs still have their own locking bytecode. So this is only like a super contract that's kind of enforced on top.
Oh, wait, where's my, what? Someone deleted that section? What happened? My favorite section is gone. Okay, so we'll have to
Yeah,
we'll
what
have
does
to
it
make this
mean?
up.
Just explain it in words. What does majority token holder unlock means?
So this is really frustrating. This is my favorite part, and and you see, it's just blank. So let me explain it in words, and
You
I
have
have to
yet to
go.
write it. You're bluffing.
So let me explain it. So
Yeah.
if up this index up pick, no, I'm just kidding. So just making up the script. So good luck understanding that. No, I'm just memeing. So let's say you have 1,000,000 USDT, right? You lock that in a normal pay to script hash output, right? You put that there. Now you have another token. Let's call this, I don't know, DAO token, right? And this is a fungible token, right? Just some random token that can be moved around, traded, whatsoever, right? Like maybe it's even like one of these simple ones that doesn't have a mint baton, doesn't matter. Now what you can do in this script that has 1,000,000 USDT, you can be like, okay, this is an anyone can spend script, but it can only be spent if the sum of the DAO token is at least, I don't know, 100,000 shares, 100,000 tokens. Then anyone who can make a transaction where there's 100,000 of these DAO tokens as inputs, they can spend that thing. It's like actually like a three opcode kind of script. So does it make sense how this works? Right. So anyone.
Yes. So I'm not sure. Like when do you want to, like the same with the wrapping contract? When do you want to enforce something through like a contract like a UTXO? And when do you want to enforce something in the preamble?
Yes. So it's a very simple answer. Preamble is anything that has to be inductive, where you basically prove the past. And UTXO on output is anything where you prove something about the transaction itself. Like, for example, do I have this amount of inputs?
But for
Right?
example, for wrapping, why does wrapping need to be recursive? Why can't it be like a
It has to be recursive because let's say let's say I do wrapped USDT and I send it around like 500 times. And then another smart contract is like, did you actually wrap this? Right. So you inductively prove to that smart contract that you did wrap this 500 transactions ago. Does it make sense?
Yeah, not fully. So what I would be
No?
thinking is that you have like a simple fungible token that you can send anywhere. And then you wrap once, and then you again have a simple fungible token that you can send anywhere. So to me, it seems like the wrapping can be done on like a UTXO instead of like in a preamble, because yeah, then on each consecutive transfer, you would still like need to hash the preamble, and the script is like having still all this wrapping logic, but
Yeah, but
the
how does
wrapping.
the smart contract like 500 transactions down the line know that you did wrap it 500 transactions ago? Like you need to prove to that smart contract somehow,
Oh
yes,
yeah,
I did
okay, I
wrap
see,
that, right?
Yeah, I
That's
see.
why you have the preamble, because basically it's like, okay, I know that the previous transaction did this, and we also know that that previous transaction, and so forth and so forth, and we know that
But you could still, like, if you design like a covenant which holds pre-minted tokens, they could still validate like, so these are simple fungible tokens with no additional wrapping logic, but the covenant could enforce the wrapping logic, right?
Hmm.
So that's
Yeah,
yeah,
I
maybe that's
guess.
my mental model from cache tokens, but I'm used to thinking like wrapping as something that's happening by an output which already holds tokens. So this would already have like a
Maybe
fixed
you're right.
preamble.
Maybe it's doable as well. Maybe it's not necessary to do this in
Okay,
a
okay. But yeah, it's
preamble.
interesting as a example. I see.
But I'm not sure. But I'm actually not too sure. Um, I'll have to think about this. This is just like something where I'm like, oh, this is like easy, right? I mean, this looks complicated, but this is just because this is again because of the laws of hashing. You can't include the hash of something in itself. If you could, this would be much like this would be just a few opcodes. But since there's the laws of hashing, I just came up with that. It's the the laws of thermodynamics, laws of hashing. You have to do it this way. So yeah, does this wrapping kind of make sense? I mean, maybe you can do it, but I'm not convinced it's possible, but maybe it's possible. But this way, it's like actually quite simple because you basically like the way this works is like, hey, did you send something to this output? And then it's like, okay, yes, you did send something to this output with this script, and then it is okay, good. Now you can mint this. Now you can mint the equivalent amount of tokens, basically, right? Like this mints out of nothing the same amount of tokens as you just wrapped. That making sense?
Yeah.
And then this basically says, did you burn the equivalent amount of original wrapper of original
Yeah, I
tokens,
see.
right? And that's why we have to do this setup with the cat hash, because we can't include the hash of this in here, basically. Yeah, that's maybe there's a different way to do it, but that's one way to do it for sure. And then this section here basically is like, it's like a DAO,
Which
right?
section? I'm not sure I see.
This one. Where you lock up funds, and then the DAO, they can do a vote. They construct a transaction that has sufficient number. It has to be a threshold, right? Like, let's say there's 100,000 tokens, and you say, okay, 50,000 people, like 50,000 shares, can spend this at will, right? They can send it anywhere. They can send it back. They can spend some of it. But you know that works because you verify the input color sum of that token. So these opcodes work also outside of preambles, and that's why it actually makes it really, really powerful. So yeah, and there's like many other things that you could do. These are just these are the ones I came up after I wrote this spec. Like I finished it and I was like, oh, this is actually really simple. And you're like, oh, let me also add a few few examples. And yeah. So there's probably like way more that I don't even know how to do. But you can see, like, for example, this, I talked to a Bitcoin Cash artist. This is not easy to do at all in cash tokens. It is possible, but you have to make some looping contract that counts up in an NFT or in something.
Yeah, we need loops in cash tokens, it's true, because you often want to enforce things about, you want to sum the inputs. That's one opcode that we're missing. Like
Yeah, and I was like, yeah, we also need loops. You can see, like, I'm kind of like giving you the finished product, but I'm not giving you all the steps in between that took like 5 years or so to discover. And I also thought, like, oh, we absolutely need loops. And then you need loops kind of for Merkle proofs, but for most things you can have a fixed sized Merkle tree, and then you just repeat the hashing, and it's not too much of a deal. And you absolutely also need loops. This is basically unavoidable for summing amounts. Like if you want to sum all the input amounts, sum all the output amounts, then you kind of need loops. But what I discovered is that, hey, this is a really complicated machinery of loops. You need to do loop counting. You need to do all kinds of things. Like the old one actually had like a really sophisticated algorithm to count loops and the inner loops and stuff like that. And it was super duper complicated. And I was like, okay, this is like fairy tale. Maybe this happens, but probably not. But then I was like, wait a second. The only loop that I ever really need is the input of a specific token sum and the output sum of a specific token. And also, this could be a normal opcode that doesn't need any like metering or something, because you just calculate this one time up front at the construction. Like you get the transaction, you do some validation, and before you run all the scripts, you just because this won't change, right? Like this is the same for every invocation as long as it's the same preamble hash. You just calculate it once up front, and then you just look into what the amount is, and it's a very cheap operation. That making sense?
Yeah.
So I'm like, yeah, this is a really, really simple design that, and who knows?
Although I think that loops also in and of themselves, for example, if you want to know all the Satoshi amounts in the inputs, like
All the what?
all the Satoshi amounts, like the total value of eCash or BCH in the inputs.
Yeah, that's true. And we can add an opcode for that.
Yeah, so we're actually like there's a chip proposed for 2026, so that's still like a while out, but to introduce like bounded loops to BCH by Jason Graysner, of
I
course.
saw that actually. Yeah.
Yeah. Okay.
I mean, would be really interesting. In my opinion, if you want to have, if you want to sum all the Satoshi inputs, maybe you can just use the existing one. Also, one thing that I thought is that like I'm not opposed to still use the what's it called? This quote unquote hack, the object datasig hack.
Mm-hmm.
And I'm like, well, if we'll change the thing here. What do you call it? The transaction format. We will also change the SIG hash. So why not just include, like I did that on Lotus. We removed it later because we were unhappy and nobody used it.
Yeah, that's the worst introduction. We added something, we removed it later, everyone was unhappy.
Yeah, nobody used it, nobody cared. That's a good thing if you have a shitty blockchain that nobody uses. You can just add stuff, remove it at will. But one thing that I did add, and I was very, very clear about that, is that the Satoshi input sum and output sum are both part of the SIG hash. So, if you really need the input sum, you could just use the old SIG hash trick in here.
Mm-hmm.
But, maybe we just add an opcode. I don't know. Either is fine with me, to be honest.
Yeah, thank you for walking me through. And I'm curious if you re-add your example, and I can see the actual opcodes.
All right. I think I might just as well do it. But yeah,
it should be in the history of Notion, probably, right?
Yeah, you're right. Yeah, now that you say that, I'll look if it's still there. Maybe I just started working on it, and then I was like, oh, actually, I can do that, and then I just started tweeting about it instead of finishing it, right? Maybe that is what happened. And yeah.
Then it was you who did it. All right.
So yeah, maybe at some point. So the timeline for this is that I asked Pierre to backport the core changes from Signet. If they add that, it's basically like ChipNet but private. Like you can just spin up your own network. It has this different magic and stuff, and it's proved by public key. And then I could write this, open a Signet for this, and people can play around with it and see if what I say here actually works. I mean, there's still a chance that it's super insecure, but I think it works. Pretty sure it works. And yeah, who knows? Maybe eCash merges this at some point. Who knows? Maybe Bitcoin Cash merges this at some point. It just has this incompatible token systems. And yeah, that's that. That's my speech.
Yeah, thanks for walking me through.
And yeah, I really need to go to eat now. My mom is already getting mad. I'm in Germany right now.
Have a good lunch.
Thank you for the explanation, and see you later.
Bye-bye.
Bye-bye.